Hi, I'm Dr. Thomason, and you've been asked to watch this video in preparation for your second visit, or the visit also known as your report of findings. And in the next several minutes, I will be going over a condition which is most likely a contributing factor to your metabolic dysfunction, known as hypochlorhydria, as you have one or more indicators for this condition. Now, if we take a look at the word hypochlorhydria, hypo simply means low or less than, and chlorhydria actually refers to the HCl or hydrochloric acid in your stomach. So hypochlorhydria literally means low stomach acid. And the consequences of having low stomach acid can be surprisingly destructive to a person's health. There are several things that can indicate the likelihood that a person has low stomach acid. One of the most common is when a person is taking antacids. Now, that might not make immediate sense to you because mostly people who are taking antacids or who are prescribed antacids are left with the impression that they have too much stomach acid, not too little. But once we take a look at the physiology of the stomach and the esophagus and how they function, this should become a lot clearer to you. So the following are several indicators that a person may have low stomach acid or hypochlorhydria. Taking antacids, heartburn, acid reflux, GERD, indigestion, lab findings of elevated serum protein, elevated serum globulin levels, elevated blood urea nitrogen, decreased phosphorus, excessive belching, burping, bloating, gas immediately following a meal, the loss of appetite for meat, offensive breath, difficult bowel movements, a sense of fullness either during or after meals, difficulty digesting fruits and vegetables or undigested food found in your stools. If you were to ask the average person what causes heartburn, they'll most likely say too much stomach acid. And again, this is the impression that we are left with after watching commercial after commercial selling antacids and doctors within the HMO PPO system of care prescribing H2 antagonists and proton pump inhibitors, which are much stronger drugs and severely diminish your body's process of making hydrochloric acid. Study after study, especially current research, show that our stomach acid secretion declines with age. It doesn't increase. Furthermore, again, as we look at the physiology of the esophagus and the stomach, the cause of the majority of the indicators that I just named will become quite clear. But first, let's take a look at how stomach acid is actually produced. Okay, so we're going to take a look at how the parietal cell actually manufactures and secretes hydrochloric acid into the stomach for proper digestion. And I'll describe my illustrations here. We've got illustrations of parietal cells. The space here represents the lumen of the stomach, and I've got an adjacent blood supply over here. So the creation or the manufacturing of hydrochloric acid begins with carbon dioxide coming or diffusing from the blood into the parietal cell. And once carbon dioxide is in the parietal cell, it'll interact with water and an enzyme called carbonic anhydrase. And the reaction goes like this. CO2 plus H2O with the catabolism of carbonic anhydrase yields H2CO3. And H2CO3 is carbonic acid. Now, carbonic acid will dissociate into two different ions. It will go in this direction to HCO3, which is bicarbonate, and in this direction it will yield one hydrogen ion. Now, if you remember, the goal of the parietal cell is to create hydrochloric acid in the lumen of the stomach. So we've already got our hydrogen. Let's take a look at what happens with that. There is a proton pump, which is a molecule embedded in the parietal cell membrane, and what it does is it does an exchange actually, and it exchanges the hydrogen. It puts the hydrogen molecule or the hydrogen atom into the lumen of the stomach in exchange for potassium. So hydrogen, when hydrogen concentration builds up in the parietal cell, it will be exchanged for one potassium ion, and we've already got the hydrogen in the lumen of the stomach. once the hydrogen is in the lumen of the stomach, we have to take a look at what the bicarbonate does. So the bicarbonate will interact with another ion exchange pump, and it goes in this direction. So you get HCO3 going into the blood, which does increase the pH of the blood, which alkalinizes the blood and keeps it at a neutral pH, in exchange for the other ion that we need, which is a chloride ion. Now, virtually at the same time the hydrogen gets exchanged for the potassium, the chloride will also diffuse into the lumen of the stomach, and you will get a hydrogen chloride into the lumen of the stomach. This is our secretion of hydrochloric acid into the stomach. This process does not get stronger as we age, it gets weaker as we age. It is very uncommon to find clinically high stomach acid in somebody over 35 or 40 years old. Most of the symptoms that I talked about are based on low stomach acid, and the research and the physiology both reflect this. So now that you have a better idea where and how stomach acid is produced, and that stomach acid production overwhelmingly declines with age and doesn't increase, let us take a look at how stomach acid can actually create something like heartburn, acid reflux, or GERD. So looking at a diagram of the stomach, we see here the esophagus, which descends from the mouth and connects the mouth to the stomach. Here we have a one-way valve which is made of smooth muscle called the lower esophageal sphincter, or referred to also as the LES. And here we have the pyloric sphincter at the distal end of the stomach. Another difference that I'd like to point out in the stomach from the esophagus is within the cells. The cells of the stomach, since they have to house and contain hydrochloric acid, which is a very strong acid, actually secrete mucus and some bicarbonate, which creates a protective layer so that the cells themselves don't become digested by this very strong acid. And this is called a protected barrier. The esophagus does not contain such a barrier. Now, the whole key in understanding how low stomach acid could possibly cause heartburn, GERD, or acid reflux is in understanding what current research tells us about the one-way valve known as the LES. First, the mechanism that triggers this valve to close is strong acid. It is literally the strength of stomach acid measured here at the antrum of the stomach, the bottom of the stomach, that triggers this valve to close. Second, what research has discovered or revealed is the actual physiologic range, or the pH level needed to trigger the close. And it is at a pH level of anything below 2.5 to 3.0. And that will trigger the close of this valve here. Now, once food is chewed and swallowed, the esophagus delivers the bolus of food down to the stomach through a process known as peristalsis, which is a rhythmic muscular contraction moving the food into the stomach. By this time, the stomach should have adequate levels of hydrochloric acid to continue the process of digestion, because everything from seeing the food, to smelling the food, to actually chewing the food increases the level of production of hydrochloric acid and gastrin in the stomach. With normal HCl production, the pH levels will drop to below 2.5 and 3, which is highly acidic, and this very mechanism will actually close the LES. Once the LES is closed, the stomach can continue its mechanical churning and digestion process. When a person has low stomach acid and the pH does not reach the levels of acidity to trigger this closing of the LES stays open. Now, whatever acid is in the stomach, even if it's not very strong, and it comes into contact with the esophagus, that will create damage and the symptoms that you know as heartburn, reflux, or GERD. Although there are other mechanisms which inhibit this LES from closing normally, such as obesity, bacterial overgrowth, diaphragmatic dysfunction, or pregnancy, it's this mechanism that actually accounts for approximately 80% of heartburn, reflux, and GERD. And acids further inhibit the body's natural ability to produce necessary levels of hydrochloric acid. So if this information is research-based, if it's available to doctors, and prescribing medication is worsening the root cause of the problem, then why do doctors continue to prescribe medication to further inhibit a system that's already producing low stomach acid? Let me just say this, that drugs for acid reflux and GERD generate huge profits for the pharmaceutical companies. More than 60 million prescriptions for GERD were filled in 2004. Americans spent $13 billion on acid-stopping medications in 2006, and the most popular medication for GERD, which I won't name, brought in $5.1 billion alone, making it the second highest selling drug behind Lipitor. Okay, so I've gone over a lot of information relating to the creation of heartburn, GERD, and reflux, but keep in mind those are symptoms of hypochlorhydria or low stomach acid. And many, probably even most people who have hypochlorhydria do not have reflux, GERD, or heartburn. So let's take a look at the actual benefits that healthy stomach acid yields. Adequate production of hydrochloric acid, or HCl, is so important to digestive health, yet so few understand just how problem-generating low HCl can be for the rest of a person's metabolic health. We're going to take a look at the 5 basic benefits of hydrochloric acid. The first of which is the sterilization of the food that we eat. Now, the food that we consume at any point in time may contain bacteria, viruses, or parasites. So having strong stomach acid levels gives us the best chance to stay healthy and free from infections like H. pylori, E. coli, and hepatitis, or common parasites like roundworm, which are not uncommon for us to see in patients with metabolic disorders. Chronic infections, bacterial, viral, or parasitic, within the digestive tract can also be triggers and drivers to autoimmune diseases or sources of inflammation, systemic inflammation, which are often difficult to identify. Next, we'll look at vitamin and mineral absorption as it relates to hydrochloric acid. HCl is fundamentally required for the breakdown and the absorption of both vitamins and minerals. Calcium and magnesium are 2 minerals which most people over the age of 50 are very aware of as being necessary for bone health and strength and preventing osteoporosis. Adequate levels of HCl are required for them both to be absorbed efficiently. Zinc, iron, and copper are other examples which depend on HCl for absorption, as well as vitamins C, K, and many of the B vitamins as well. The next benefit we'll look at is enzymatic conversion and stimulation. HCl is responsible for the conversion and stimulation of a myriad of digestive enzymes, which, if not triggered, can lead to nutritional deficiencies. Enzymes are responsible for the digestion of proteins and fats, both in the stomach and downstream in the digestion process. The next benefit that we'll look at is bolus motility, or the coordination and movement of the food. Proper acid levels are what facilitate opening and closing of smooth muscle valves throughout the GI tract. Now, the timing and movement of your food within the GI tract is crucial for optimum nutritional absorption. And last, and certainly not least, benefit of HCl is barrier health. Now, intestinal hyperpermeability is where the barrier of the small intestines is made more permeable or leaky than it should be, allowing food which is not ready to enter into the blood supply across that barrier into the blood supply prematurely. There's an entire video description on this subject that you can refer to for more information. So in summary, it's low stomach acid, not high stomach acid, which overwhelmingly causes symptoms of heartburn, GERD, and reflux. In the case of low stomach acid, taking medication which intentionally interferes with the body's ability to create hydrochloric acid not only doesn't make sense, it causes further metabolic damage. Ignoring low stomach acid dramatically increases the amount of bacteria, virus, and parasitic load which pass beyond the stomach into the small and large intestines, increasing a likelihood for chronic infections. Chronic low stomach acid is a contributing cause to osteoporosis, and low HCl decreases vitamin and mineral absorption. Low stomach acid contributes to malnutrition. If you do not correct or increase your stomach acid levels, you will not be activating enzymes that you need for digestion and absorption of nutrition. Low stomach acid will interrupt the normal motility or movement of the food bolus through the digestive tract. And finally, HCl is detrimental to the barrier and health of the small intestines. Again, this factor is so important and has such an impact on your metabolic health that there's a separate video dedicated entirely to understanding barrier health or leaky gut syndrome. This concludes the informational video on hypochlorhydria. Please watch all videos that you were recommended to you prior to your second visit. Thank you.